Okay, let's start. Welcome everybody. We are already near to the end of the conference, but it's good to see that we still have a lot of audience. So I think it's a good sign. Still, everybody seems to be here. Yeah, this session is about. I don't have an image here. Oh, it's because okay. So this session is SYM17, which is about discovering the potential of fair digital object annotations and how you can use them. That's the first presentation. So this session is about annotations. We have 5 presentations in this session. The first 2 will be virtual. But I hope that the presenters are online so that we can ask them questions afterwards. There is sometimes about 15 minutes after the presentations for further discussions if the presenters keep time, so please do. I would like to thank the sponsors of the conference for making this session and all the other sessions possible. The questions that the online audience is asking, we will monitor them so that we can also answer them. And please, I would like to remind you that the session is also going to be recorded and the recordings will be made available afterwards. So let's start now with the first presentation. Thank you.
Hello and welcome to this presentation about the potential of fair digital object annotations and how you can use them in Disco's main user interface called Discover. My name is Tdwg and I'm one of the developers working on the core technical infrastructure of the Disco project. And together we are aiming for our first minimum viable products at the end of this year. And we want to give you a sneak peek upon the annotation services. So right off the bat, what is annotating? Well, annotating is a mechanism that is widely used to make suggestions upon existing work, for example upon literature, with the aim to improve or modify it. And when it's shared with the author, it can often improve the original work for the better. Or in the case of Tom Riddle, you can keep it to yourself and become the greatest potion master there ever was. But all jokes aside, with the concept of annotations, just think of the potential of digital specimen annotations. For example, we can enhance research capabilities and track changes over time. Think of conservation efforts like annotating endangered species to inform conservation strategies, or work on scientific collaboration and facilitate data sharing in interdisciplinary studies. And within Disco, annotations exist to create additional value, as they help create extended digital specimens. Ultimately, this provides more value to potential users of these data. Remember that annotations are suggestions and still need to be curated and accepted to become part of the digital extended specimen. Annotations can also be automatically generated by things we call machine annotation services, which often use machine learning to detect new values. These also still have to be curated by human users, of course. And finally, we provide batch functionality that allows the annotation of multiple digital specimens or media at the same time. So, extending digital specimens. With the annotations, the main goal is to work towards a benchmark for extending digital specimens. And we want to provide the tools, but also the data necessary to make extensions possible. And this can be anything. For example, a user that wants to add sequence data to digital specimens, or thinks the species name should be corrected. But it can also be a machine that plays a role in providing automatic detection of new values, like for example coordinates based on a given location. And all this new information helps create the extended digital specimen. And this annotation process is made possible by our digital infrastructure, wherein the user interface application Discover, what you see here, acts as the main interaction point for users. And Discover has 2 main functionalities. The first is to search for and discover digital specimens and associated data like digital media. And the second is to make annotations upon these data. From a technical perspective, annotations have the following traits. They are fair digital objects and thus have persistent identifiers called PIDs. Fair, of course, meaning they are findable, accessible, interoperable, and reusable. And we structure the annotation objects using the W3C web annotation model, which means it has a target and a body, as you see on the right side. And annotations can also have 5 different motivations. And these are all more technical terms, so let me explain in a bit more detail. Starting with the annotation target, which specifies on which part of a digital object you are making an annotation. In our case, being a part of a digital specimen or media. And a digital specimen contains lots and lots of different classes and terms, which adhere to the Open Digital Specimen Classification, OPS for short. This mostly reuses existing terms, for example from Darwin Core and ABCD. And OpenDS is structured using the JavaScript object notation, JSON for short. On the example on the right, you see how a digital specimen acts as the main class with the inner levels holding different subclasses. It contains an event class which holds the location, a georeference, and which eventually contains the latitude and longitude terms. So classes can contain terms and other subclasses and so on. And using a principle called JSON path, we target these nested properties. By providing the full chain of levels the program has to move through to get to the correct target. The annotation body holds the values for a term or class that is annotated, and a value for a term is always a simple type, like a string or a number as you see here. A value for a class is always an object, holding values for all the terms inside a class that are annotated, like the georeference holding the latitude and longitude. Values are always held in a list, allowing multiple strings or objects to be present. And finally, the annotation motivation. So it's common to think annotations mostly exist to add information, but in fact we support 5 different motivations that identify the purpose of the provided information. And the image shows which motivation are applied to which kind of targets. The region of interest target meaning a visual boundary on an image. So comments apply to all, additions only to term and classes, same with modifications, assessments again to all, as well as deletions. So with this theory in our mind, let's see it in action and have a little demonstration of Discover. So now we're here in Discover in our application at sandbox.disco.tech, and you can test this yourself actually if you go to this web page. And we're first going to search for a specimen. So I have a global identifier with me today, which I'm going to use to find the specimen. So I select physical specimen identifier, global, and provide the ID, which directly leads me to the specimen overview page. And this page provides all the necessary details and information surrounding the specimen. So we allow the user to make annotations upon this data. And as you can see, there are no annotations yet. So let's make a new annotation upon this data, because I know there's some missing information in the location. So first let's select the location class. And well, we can annotate this class instance or annotate one of the fields inside directly, but let's choose the class instead. So we see it has a locality and a country, and there's still a lot of missing values we can insert. So let's correct this. It's in Suriname, so this should be South America. And then once we save, we make a suggestion for this specimen saying, okay, well, the continent should be South America. So this, now we have made our first annotation, and remember this is a suggestion, so it's not in the extended digital specimen itself. So I also want to show the machine annotation services, which can be triggered via the interface. So for example, we can pick the gbif occurrence linker, and this is a machine annotation service that tries to link our record in Disco to a record in gbif. So it tries to look up a gbif ID that matches or details of the specimen we have. So let's schedule it. So it's now scheduled, and these services take a bit of time. So in the meantime, I can explain a bit about how this works. So the machine annotation service runs in the background, does its process, and returns are an annotation. And these annotations are also still suggestions, so there's always a human factor involved in accepting these annotations to become part of the specimen. So there it is, it's completed. So you can see the machine annotation service finished, GWF occurrence linker, and it added a new annotation with an entity relationship, which means a new relationship to an external service, in this case GWF, and has an ID in there. And we have this nice little graph that shows the annotations in there. So we now have a GWF ID, and if we click on this little dot, it will take us to the specimen which it linked toward. So I think this is right because we have the same kind of photos like we also have in here. So this is how we link our specimen, and this is how MS works with annotation. So there was a very quick demonstration of how annotations work, like manual annotations by user and a machine annotation service. You can try it yourself at sandbox.disco.tech, and remember it's still in development, so we're always working on it. Finally, I'd like to thank the Disco dev team in Naturalis for all the effort we put into this the last couple of years. Yeah, and have a great conference. Thanks.
Thanks, Tom. That was a nice presentation. It was a bit fast, so I hope that everybody could follow it. But if not, then maybe you can watch the recording afterwards to look at it again. Tom is also online to answer some questions. I would also like to add that this presentation is made possible by European funding to the DISCO transition phase project. Are there any questions online?
No questions.
No. Question from the audience. Yeah, I see at least one.
Hello, thank you for your presentation. Not so much a question, but maybe a comment. My name is Jason Best. I'm with the Botanical Research Institute of Texas. And I'm happy that you included specifically machine annotation, because I'd like to consider maybe annotation-enabled platforms will allow us to make machine annotations while reducing monetary costs, because many of us may want to make the same annotations such as OCR, computer vision, et cetera. But as Patricia mentioned, I think yesterday, there's an environmental cost to this as well. So perhaps by pooling our annotations that are done by machines, we can reduce that cost, both monetary and environmental costs. Thank you.
Thanks. Tom or Sam, do you want to comment on this?
No, yeah, I think that's an excellent remark. So with Disco, we're trying to create this platform where where you can run the machine annotation services, and it will provide it, generate the annotation and attach it to the specimen, and we can also push it back to the original source, but also to any other. So we're having this event-based structure where we can push our results to any other system that wants to get hold of that annotation. And for example, especially with batching, this was one of the things we had on our mind, that if the same parameters are used, and we know we get the same annotation, so let's say we georeference Paris, then we basically know that all the specimens with locality Paris will have the same annotation. So that's why we created this kind of batching functionality, where if we know that all these specimens will comply to the same properties, to the same requirements, we only have to run the georeferencing once, and then we'll attach the same annotation to all the different specimens, all the different specimens with the same properties, with the same values. So yeah, this part of the green IT movement is part of our goals here. That's also why we scale back all our services until we actually get requests in. Then we scale up temporarily and scale back to zero again. So yeah, we're trying to reduce our footprint as much as possible.
Okay, thanks.
So there's a question in the chat. Alan Stenhouse is asking, how do annotations then get curated? Are there communication mechanisms to notify human curators?
Yeah, that's a good question. Yeah, it's still one of the points that we'll have to have to work on for the next year. So we're generating annotations, and we know how to do that part, but we're still researching on how we can get annotations accepted. So we don't want to overload the humans with instead of before they needed to make each annotations, but now we create them. The machine is creating all the annotations, but now we have a gigantic load of humans again for curating all these annotations. So there will need to be a balance, and yeah, we're still researching if we can make some kind of scoring mark. So if the annotation is relatively uncertain, we need to have a human in the loop. But if we're if we're based on certain values, relatively certain that this is a good annotation, that we automatically accept it. So this is still something we have to experiment with and learn with, where the boundary is between what humans, where we really need humans, and where we can leave things to machines. Yeah.
Okay, thanks. We need to move on to the next presentation. So next presentation will be given by Sabine, who is also online.
Hello and welcome to the talk Advancing Community Curation of Research Expeditions that I'm presenting on behalf of a group of colleagues, and that shows our collaborative journey with Wikidata, Biodiversity Information Standards and Tdwg. My name is Sabine von Mehring. I'm a biologist and data scientist based at the Museum für Naturkunde, the Natural History Museum in Berlin, Germany. Research expeditions are an important source of specimens and objects in natural history collections. Expeditions can be quite diverse, for example, in terms of size, duration, destination, and form of transportation. To further open up and increase the accessibility of such collection data, there is a need to link historical and contemporary research expedition to other entities, requiring the unambiguous labeling and persistent identifiers of such events. Stable identifiers for expeditions, plus the sharing of metadata and descriptions, will facilitate the linking of material distributed across museums and related research data. We originally started out as an informal international working group interested in the topic of expeditions and exploration. Most of us had used Wikidata before, and we wanted to explore if this knowledge base could be used to store metadata for describing research expeditions. A wiki project was created to document the work progress, to share resources, and to connect with the wider community of Wikimedians. You can see a screenshot of this wiki project on this slide here. Even though most of you might be familiar with Wikidata already, I would like to give a quick overview. Wikidata is an open and community-curated knowledge base containing structured data in a human and machine-readable format. It can be edited by anyone. It is multilingual and a collaborative tool with a large, very active user community that curates the data. Wikidata also serves as a hub for other identifiers, for example, from identifiers from specialist databases in the field of biology to identifiers of national libraries and many more. At the Tdwg conference in Tasmania last year, we proposed an official Tdwg task group that was approved earlier this year. The new task group Modeling Research Expedition is now a task group under the Collections Description Interest Group. It aims to create best practice recommendations and guidelines for the modeling and linking of expedition data, as well as to create a terminology, terms and definitions used to describe such events. Our task group charter can be found on the Tdwg website, and there's also a GitHub repository which will be used to document the work progress. Let's have a closer look at an example of a historic expedition. In this case, the first German deep sea expedition, known as the Valdivia expedition that took place between 1898 and 1899. It is named after the research vessel with the same name that you can see here on the photograph. This slide shows some participants of the expedition, how they are linked to the Wikidata item of the Valdivia expedition, including information on their role during the expedition, for example, as the expedition leader, as a zoologist or marine biologist on the ship. To increase transparency and accessibility of the collection objects, links are made in Wikidata to the natural history collections holding specimens gathered during the expedition. If available, a link to the stable identifier of the specimen should be added as a reference. We are also including statements giving information in which archives relevant archival records, such as field books, logbooks, correspondence, or whole estates of expedition participants are deposited. All these linked open data can then be can be queried, can be reused, or used to visualize a topic in a knowledge graph. This preliminary knowledge graph was created using Scholia, and Scholia reuses data from Wikidata. Shown are links to other relevant entities such as participants of the expedition, publications of scientific results, and the collections where specimens are held. This map of an expedition by botanist Inés Mejía is the result of an automatic query that searches every day for Wikidata items for research expeditions and checks if an itinerary and specimens are available in GBIF. If such information exists, a map is created with each point of the itinerary and the specimen. Visitors can visually explore the itinerary and get additional information about the places visited. The script was developed by Joaquim Santos, a colleague, and is an example of a visualization built in the scope of our task and working group. It is also possible to pull information from external sources such as GBIF when the published specimens provide the collecting event with a Wikidata identifier of a research expedition using the Darwin Core terms event ID or parent event ID. This practice is not widely adopted yet, as we are still working on guidelines on how to properly describe research expeditions. For this particular case, we have manually queried GBIF for collector and date range and added the resulting list of occurrences to this research expedition we were interested in. A little outlook. We are currently developing a formal set of terms and definitions and a best practice documentation for modeling research expeditions. We have already created a schema of properties used in Wikidata. We are also describing additional historic and contemporary expeditions in Wikidata, and we are encouraging the implementation of identifiers for expeditions in collection management systems. This work also links to the work by Siobhan Leachman, who has been working for the Museum of New Zealand Te Papa Tongarewa. And in case you missed her talk on Monday, check out the recording. We also want to explore if GeoCycle, GBIF's global registry of scientific collections, could be expanded to include the normative identifiers for research expeditions. Or if, for example, Bionomia could be expanded to link natural history specimens not only to the world collectors, but also to expeditions. The whereabouts of expedition participants can be used to validate Bionomia annotations for collectors. Participants in a given research expedition can guide suggestions for Bionomia annotations on specimens linked to the expedition. Thus, the expedition data will also support quality control of collection data. Such open data trigger contributions, annotations, corrections, and also the development of new tools or new data standards. I would like to thank our task group members and the wider community, both in the natural history collections world and in the Wikiverse. Please get in touch if you are interested in expeditions and how to model expedition data. The QR code on this slide will lead you to the website of the Tdwg task group. Thank you for your attention.
Thanks. We have time for some questions. And no online questions. And yeah, I see a question there. Come to the microphone.
Hello, Sabine. This is Marie from GRCycle. Thank you very much for your presentation. I think in GRCycle we have some expeditions that are entered. I was wondering if you already have thoughts of like how best this should be represented in wider platforms like GRCycle or even Bionomia.
Yes, we are currently discussing the different options and discussing what the best way would be to connect to a stable identifier for expeditions. What we are currently using is Wikidata, as we have just explained, as a proxy identifier that should then be linked somehow, and it could be a separate Darwin Core term that might be included in the standard, or it could be we could reuse one of the existing terms such as parent event ID or event ID to include some of these terms. But currently not all of this information is shown, for example, in GBIF or in GRCycle. Also, of course, Latimer Core could be an option how to connect. But this is definitely something we are still discussing, and we are also interested in ideas of other colleagues who are, have ideas what the best way could be to model this. And but we hope that there will be places like or Bionomia where we could connect also directly to the expeditions.
Thank you. I think that there is, even if GRCycle is not the central place for this, it could remain in Wikidata. I don't know. I think there is a lot of potential for at least linking current collections with expeditions. That would be quite helpful. Thank you.
Okay, we have time for another question. Yeah.
Hello, Sabina. This is Andrea Weeks. Thank you for your talk. So the examples that you gave were retrospective. These are historical expeditions, but there's a lot of movement now with born digital data. Expeditions are happening now. And so my question to you is, are you envisioning a best practices document for current day people, setting out on very large collaborative expeditions?
Yes, we do, definitely. And there are already some examples where this is used. For example, our Norwegian colleagues linked to GBIF Norway and Doug Andresen's work, they are already, some colleagues are already using it for current day expeditions, for example, to the Arctic or Antarctic. But we are also in touch with some other groups who are developing ideas for current expeditions. And I feel really a need that there are identifiers and that we don't add to the backlog that we need to disambiguate again then in 20 years who was part of this expedition, where the material is housed. So we should definitely think about this now, have identifiers to be used, and then have all the metadata connected that we can use them automatically and connect them directly.
Thank you.
Okay, it's time to move on with the next presentation. And that is a presentation from Elspeth. This is about completing the completeness measure.
Yeah, thank you. And yeah, it's great to see so many people here and hopefully online, but I can't see you. But I'm glad to know that there's some people there too. So some of the things I'm going to say are kind of stating the obvious, but I'm going to do it anyway. So the number of collections that have been making progress in mass digitisation has really increased hugely over the last few years. We're aware that the cost and difficulty in transcribing some of the labels associated with the specimens has really required an approach that prioritises capturing parts of the data based on both research and curation requirements, as well as ease of transcription and methodology available. So what this has meant is that over time there's been a wide variation in the completeness of data capture and imaging of specimens within and between collections. The speed at which a collection transitions between these stages and when and how images are part of this process also varies. So MIDS doesn't really focus directly on data quality, and the distinction between the presence of data and the quality of the data present has been a really important one in the development of MIDS, and there's been a lot of discussion over time about exactly this topic. However, completeness itself is part of the journey towards data quality, and MIDS can be seen as a tool to support the continuing improvement of data access and quality. And it provides guidance for prioritising the data to be captured, as well as recommendations for data standards and mapping structures. So the 4 MIDS levels have now been defined, and the MIDS information elements for each of these 4 levels have also now been defined. This includes the recognition that different requirements for biology, geology and paleontology should be recognised, and a draft version that you can see here, but a draft version of the MIDS levels and the MIDS information elements are available on the MIDS GitHub, and there's a link to that just on the right here. Other work that's been done, the SYM17 mapping, a machine-readable mapping to Darwin Core and ABCD, has been compiled following the SYM mapping standard. And we intend to use the SYM standard to effectively map the elements of each MIDS level to terms as used in common data standards such as Darwin Core or ABCD. So there are currently 2 implementations of MIDS calculators that have been developed and that are available to test. And there are additional implementations, such as the one being incorporated into DISCO, the European Scientific Collections Research Infrastructure. So the MIDS calculator, developed at Mesa Botanic Garden, uses a zipped GBIF annotated Darwin Core archive. So this enables the user to define their own dataset from GBIF, and it also enables the implementation of value permissions for some of the information elements. And the aim is also to extend the MIDS calculator developed at Mesa Botanic Garden to include any valid Darwin Core or ABCD2 biocase archives. That's the plan. Secondly, the MIDS checker, developed at the Natural History Museum in London, interacts directly with the GBIF API. So this allows a more direct calculation, but it is constrained by the data available via the API, and it's also restricted to predefined datasets in GBIF at the moment. So initial exploration of a range of datasets in GBIF are providing reassurance that the MIDS levels, certainly up to MIDS level 2, are achievable, and they are being reached by quite a few collections, while still providing some targets for increasing completeness of some of the key data fields. We are aware there's currently a slight bug in the event date, but hopefully we'll get that resolved once we understand what's going on. So MIDS level 3 is a more ambitious target. But we are already seeing some collections, including a number of identifiers in their data. And what's really interesting is when we look at some of the institutions who are putting a lot of work into the identifiers, we're seeing visually, we're seeing the impact of that. If we look at, for example, the Oslo data. So as I say, that can show very visible results within the MIDS framework. So we've carried out most of the implementations. We've been focusing mostly on the biological collections so far, but we are now increasing focus on the geology and paleontology collections. Some of the repositories for these are more challenging. However, looking at a paleo dataset from Naturalis, we can see that early indicators are good, that the framework should work for these disciplines as well. And just finally, from our own experience at the Royal Botanic Garden, Edinburgh, in the herbarium, we can see that the tools can be used to help identify data not yet available in GBIF. So these data are also often captured in the collection management system, or they may be easily included in the static metadata for the dataset being uploaded. And they may just not have been mapped yet, or there may be some issues in the mapping during the export process as well. So we were able to identify some key data not being made available on GBIF using the MIDS checker. And then we modified our GBIF mapping and export. And we could easily see the impact it had on our data in GBIF. So these tools are both available for you to try out. And you can do that as I wrap up. The links are here. And we'd be really keen that people do try them out, see how you get on, test your own data sets, test other people's data sets, and then get back to us. Let us know. You can provide feedback in the MIDS GitHub using the issues. They're still in development, and there will be some really helpful feedback that you're going to be able to give us that will make them even better, so we'd really appreciate it. So finally, I'd just like to thank everyone who's been contributing to the Tdwg MIDS task group and to the technical architecture group for some really good feedback, as well as to the CTAF community who've also been helping with this as well. And then thank you very much for listening. And yeah, I would just send us feedback. That'd be super. Thank you.
Thanks, Elspeth. We have time for a couple of questions. Are there any questions online? No? Yeah, Klaus, go ahead.
Yeah, thanks, Elspeth, for this talk. And sorry that I didn't follow up, so maybe it's obvious what I asked. When you introduced this with Alex Hardesty just a while ago, I mean, there was the idea of MIDS leading directly, stepwise, in 3 steps, so to say, to the digital specimen compatibility. Is it still underlying somewhat that MIDS 3 corresponds to the digital specimen concept in DISCO, or is it decoupled now?
I think the aim was that the MIDS 3 would become the very related to the extended specimen. The idea that we have at the moment with the MIDS3 is that it's where the linking comes in. It's where you can reach the additional data. So the identifiers are to provide the links. MIDS3 is probably the one that we're kind of least finalized on, to be honest. So yeah, it would be good to get more discussion on that with the OpenDS and the extended specimen groups, so we can see how they work together.
Any more questions? Yeah, Deb, go ahead.
Hi.
Hi.
It's Debbie Paul, for those of you who are online. Hi, everybody. So Elspeth, thank you. And I know MIDS has been a lot of work. You put a lot of hard work into this. I was very interested to hear from early conversations you and I had, the point you made about MIDS becoming a tool for you to see, at your point, things that you weren't sharing, that you may or may not have realized were not going out the door. So it shows you the concept of just how hard or complicated that can be. I heard of somebody once telling me that they had mapped their locality versus verbatim locality, like to the wrong thing. And so it wasn't ending up where it needed to be at GBIF, and they were unaware. So what I was thinking is it also points out the need that I've been saying for like TaxonWorks, where as you go through time, how do you know what's in your own database or not? A lot of you people in here will be familiar with the concept of a skeletal record, people that are doing digitization where they're only capturing a few fields till they can mythically, magically go back later and fill out the rest. And so this notion of we move on, we expand our careers, we change, we move positions, we retire, and who has that knowledge of what is or isn't in your database, or what is potentially could be filled out that isn't, and how do you know that? So we need this at all different levels. So that's cool that that adds one extra level to this picture of how do I know, what we could add, could we? And then your local knowledge. And I'm trying to get inside TaxonWorks this notion, we have a thing that shows completeness of a sense, of a kind, but it's still the collection manager or the data manager who knows that they got a grant and did X, but not Y. The database doesn't know that. Yeah. So it'll be interesting to see how we can tie MIDS to those kinds of things as well.
And I think, MIDS does serve different purposes to different people.
Yeah.
We're very aware of that. But also, it can be a really useful tool, for example, in funding. Very often, institutes will get funding to digitize their collections. And very often that funding covers the basic digitization, if you like, to MIDS level 1. And then this can provide that tool to show, actually, we're very sorry, but we need additional funding to get to the next levels of digitization. And just making that clearer as well can be really useful. It, as I say, also helps people provide prioritized data. One thing that we find when we're doing this, there's probably 2 bits of information that are the most common that institutions will fall down on. And that is the modified date and the essentially the kind of specimen. And they're the ones, and especially kind of specimen, that's the one I think that most people will fall. No, next level down. So very often mapped to preparation. Mm-hmm. Yeah, whether it's a herbarium sheet, microscope slide, pinned insect, that's the bit that most people don't have that in. Seems to be.
Okay, thanks. We need to move on. So let's move on with the next presentation from Matthias. This is about enhanced round-tripping of crowdsourced specimen annotations.
Yes, thank you. And specifically, it's going to be about DoThat, which is the crowdsourcing platform that we have been running at Meister Botanic Garden for a few years now. So I'm first going to describe a bit what DoThat is, what it has achieved so far, but also the outlook to the future, which is where the enhanced round tripping and the crowdsourced specimen annotations come in. So DoThat, it's indeed not pronounced DoThat because it's a Dutch word, is a multilingual crowdsourcing platform where we invite volunteers to annotate images. And those annotations can take any combination of tasks. Oftentimes it is transcription, so transcribing typed, but in particular handwritten text or combinations of the two, because handwritten text is still one of the problems that is not completely solved by AI so far. A second one is classifying this text in the right categories, for instance, Darwin core terms. But there's also interpretations being made to these types of images. So georeferencing is one that we have very commonly done to our specimens, but there may also be other kinds of quantifications, and there may also be tagging. For instance, if we have photographs in or old postcards, there may be interpretations of what they depict or who the people are on them or what occasions they show in the past. And obviously there's also a strong element of user feedback, of interactions between users to together solve some more complicated tasks, and validation of their contributions. So we typically send user feedback to the newer users to see how they're doing. So what's the current status? We launched this in 2018, so it's already more than 6 years going. It was forked from the older Australian Digital platform, so much kudos to them as well. And it was forked to support more languages than just one, because we are in Belgium. We need more languages, as always, to Belgian politics. And in those years, we have now achieved more than 1,000 active volunteers, so who have at least done one task. And we are more than 650,000 images annotated this way. Typically, the tasks that we run are an image, and we ask for all the information of this image. So the different types of data on the image are not separated between different users. So these tasks can be quite substantial in some cases. We have also, beyond our own content for our herbarium, we have also used this platform in national and international collaborations. So it has been featured in quite a few European and regional research projects. You can see the acronyms on the slide. But also we have done some national collaborations in Belgium, including with the digital humanities, to put other types of content on their natural history specimens. I've compiled some statistics as well. So this graph shows a breakdown of different types of tasks, cumulative over the years. So you can see that the biggest chunk has been specimens from our own herbarium, being transcribed by our volunteers and georeferenced in most cases. We have also had a selection of camera trap footage from our garden for quite some time on there, but we have discontinued that, not because it wasn't popular, but because we couldn't keep up meeting demand because they were just done instantly and we hadn't the resources to keep maintaining this process in the garden itself. Content from other partners seems a bit low in this graph, but it's actually nearing the 100,000 mark, and it's quite diverse in what we have seen on there. You may also see on this graph that there is sort of inflection point in early 2020, which is when the pandemic hit the whole world, and the pandemic seemed to have made quite some people much more interested in doing crowdsourcing online. You can see this more stark in this graph, which shows the registration date of users and their cumulative count over the years, with a massive bump in 2020. And I've also added a graph of activity of our forum, where quite some discourse happens between users on complicated tasks. So just so that there has been some activity of this feature over the years, so it is definitely quite important to these sorts of platforms. Here are some screenshots, and I'm going to go over them quite quickly because the URL to do that is on every slide, so you should be able to easily find your way there. This is the introduction page showing all the projects. This is an example of a rather extensive import template, which shows the different kinds of information we request from our users. Some are with drop-down lists, but some are free text. It depends on the type of data. And this also shows the link to the mapping tool, which makes use of Google Maps plugins so the users can easily georeference the specimen using point coordinates, but also the uncertainty, making it much more useful for downstream use when we publish these things to GBIF. As this screenshot shows another type of project, so this is from the humanities. These are old postcards of cyclists, where, for instance, we ask, do you know the person who is shown on this picture? Sometimes it's written on the card, but not always. In this kind of case, it's more interesting to not just randomly assign a task, with that users may be able to pick the task from a sort of overview, and that's why we had this feature implemented. So they have more control over what they can do, and they have maybe they can more directionally see the content that they know more of, rather than just randomly being assigned the tasks. But of course, this platform has been running for quite some years, and the code base dates even back further due to being folks from Digivol. So we have encountered some issues over the years, in particular as interoperability has become much more prominent, as new frameworks arise in that field, and this creates some sort of problems for our platform. The images that are hosted currently on the platform, they are hosted there. They need to be uploaded in server storage, which is a considerable task that needs to be done each time. It would be more ideal if they could be automatically loaded from a decentralized other image server, but that's currently not the case. The input templates where the users can import their information, they need to be mostly manually still configured. Some things can go more automatically this way, but it's still not optimal. And a lot of these, so this means that if you make a new project and you need to tweak the import template a bit, this can be quite a lot of manual work for the administrators to do, setting up new projects quite resource intensive. The viewer has limited functionalities because it is hard-coded in the platform. It's not a third-party piece of software. There's API access even to the annotations, but it is limited. It doesn't work well at scale, and it's currently undocumented, and it doesn't include all the information that you would want to. There's some limited provenance tracking for the annotations, but that's also insufficient if we want to go ahead with what was shown in the first presentation of this session by Tom. So to summarize, we're struggling a bit with an aging and a complex code base that is not so easy to maintain, in particular in the long run, and we have quite some desires that are not easy to implement in such a framework. Because of that, we are looking now towards a DoThat 2.0, which we are actively thinking and working towards. Securing the funding is another measure, but we have some things ongoing for that. One of the big ones is that we want to integrate this with the IIIF framework so that we don't have to load the images into the server itself. We can access them decentralized through the IIIF APIs. This also standardizes the access. We don't have to reformat, resize images ourselves, see that they're not corrupted. That's all taken care of by the IIIF standards. We can integrate a viewer this way with extended functionalities, not having to maintain this one for our own in our own portal. And ideally, we could even read and feed data through the IIIF standard, API standards, as the manifests that underlie the whole IIIF framework. Related to that is indeed how we want to be able to mobilize these annotations. Currently, that's mostly done by CSV exports, which take quite some time and are not easy to access by all the different users of the platform. So we want to change that to more availability through the API. And in the longer run, we want to be able to connect these to actual persistent publication infrastructure, so that's nano publications or the Disco annotation API to specimens, so that we can seamlessly connect what is being done on DoThat to these publication infrastructures, which then also can take care of the provenance and the persistence of these types of annotations. And another thing which I mentioned earlier, configuring the projects currently is quite a bit of work for our administrators, and this makes it also much more difficult for content providers to know what's possible and to come up with their own suggestions, because it's always a back and forth to see what can be done. If you have an open data model for how these import templates are supposed to look, it'll become much easier to load more and more projects on this kind of platform. There's a big caveat, of course, with these sorts of big upgrades, in that the inner workflows of the platform that are shown to the user, they have been quite successful over the years, as I've shown in the statistics before. So this part of the platform we definitely want to keep. It's mostly working on the in and out, which is mostly for the providers and for the administrators of the platform, that we want to change things. So that's sort of our dream of having a DoThat 2.0. Maintaining such a platform is not straightforward, and there's a lot of people and institutions and funding to thank. There was lots of funding that went into developing of the platform and sustaining it over the years from the Flemish government, from the FWO fund, but also much thanks to the DoThat team maintaining and administrating this platform as an institution takes quite a lot of different skill sets from different people. So there's a lot of people involved in keeping this around. And of course, last but not least, all our volunteers, because without them, none of this would work and be possible. So thank you. And if you have any questions, I'm ready to take them.
Are there any questions online? No. No. That's a quiet audience online. Klaus.
Yeah, Matthias, thanks for the talk. Two short questions. How do you handle or deal with quality control? I think you have probably some redundancy here, or so if you have 650,000 images, probably all in all you have over 1 million or 6 million images checked, each one 10 times or something like that?
No, so each image is a task, and that's what I meant with the 650,000, which means that attached to that image are multiple annotations, which could cover the whole mid-spectrum, for instance, for an herbarium sheet. So if you count them as individual annotations, it's much more. In terms of quality control, we have a validation feature implemented in the platform. So in principle, every contribution can be validated by a user with the required rights. That is, of course, that doesn't scale and it's not practical. So typically, we validate a subset of each project. Some external partners, they validate much more. That's a bit more up to them. But what we focus on is giving feedback to newer users in how they are doing. And after some point, we trust that the users are experienced enough to give us qualitative enough specimens. Downstream, when we export them, there are still some automated quality checks on the data that
Okay, was much simpler my question. You don't let every image review by 10 users or so in parallel? No, only once?
Once, or possibly twice if it's validated.
Okay.
It is possible through the forum that a user, before submitting a task fully, asks for feedback from others, and they can assist this way if they're having trouble with the task. But the setup is indeed designed one user, one task, to avoid the complication of having to find a consensus if users disagree with each other, and to just gather all the data in a single input form.
I mean, if the users would disagree, that means there's something to disagree about, right?
Yes, indeed.
So wouldn't you want to catch that instead of saying that they're okay records?
Yes, I mean, other platforms work differently. For instance, what Anton is going to present in a few minutes works differently that way. And there is something to be said to both approaches. This way, we capture our data immediately, and we don't have to worry about that problem of doing the consensus. And in particular, we don't have to worry about configuring it is this way, that different users provide different content, which also requires quite a bit more moderation, because there's not one person who can sort of claim the task as having completed it fully. So it's a different kind of user interaction that you envision this way if you set it up like this.
Okay, thanks. We need to move on to the last presentation. The last presentation is done by Anton.
Many thanks. My name is Anton Günsch from the Berlin Botanic Garden, and thank you for the opportunity to present our activities around transcription of herbarium specimen labels using citizen science methods. And indeed, this is a bit different from what we just heard, but it's also similar, but also different. Let's see. The background is well known to you. Digitization processes became very fast over the last 10 years due to the availability of modern digitization hardware. As you can see here, I think this is the Paris digitization hardware and some smaller systems also displayed here. And also the availability of high throughput workflows to handling the processes. And as a consequence, we have now millions of digital specimens which literally are waiting for the associated metadata to be captured. And this is becoming now the major cost factor actually for herbaria. And web platforms such as Tdwg, not Tdwg, which we just saw, and the French Les Argonautes system are addressing this very problem with citizen science methods. And this we found attractive 10 years ago in the Botanic Garden Berlin, when we saw all the presentations about, in particular, Les Argonautes, which started then. And we decided, yes, let's do it in Berlin as well. And we then spoke to the colleagues in France, and they offered us the software, and we translated it into a German version, which was pretty straightforward. And then actually we didn't know what to do really. How would we tell the citizen scientists that they should come? And we then organized a little workshop during the Berlin Long Night of Sciences, and you see a few people mildly interested in what we are doing. And yeah, we were a little bit desperate actually, because we actually didn't know what to do. But there was a journalist attending the workshop, and he then wrote a little article in a local newspaper, and suddenly people got interested and started to register doing things. And now fast forward 8 years later, we have 620 registered citizen scientists who entered 2 million contributions, data contributions to the system. We have now really a high media presence, so the public is interested. We have numerous newspaper articles, radio features, even several features on television. So that's really popular for some reason. And most importantly, the method led to extremely high data quality. I cannot, of course, not quantify this really, but we have presently a bachelor thesis running at the Berlin Botanic Garden analyzing this in detail. And we can already say it's really good what the citizen scientists are doing here. So how do the Herbonauten work? It's, of course, it's an online platform. You can see a screenshot here of the platform. We create packages, which we call missions, bundling usually between, let's say, 5,000 or 50,000 maximum specimens, which are then linked to some kind of scientific story to keep the citizen scientists interested and motivated. And to date we have 47 missions launched, most of them completed, of course. Then if somebody registers and wants to help us, they must first complete an online training course, which is a quiz-like thing where they learn the basic concepts of label transcription, and also what the different data elements means, where do you find the collector, where do you find the collector number, and so forth. And once you have successfully run through this quiz and teaching part, so to speak, you can start to become productive. Then this answers a little bit Klaus' question over there. We are entering all information several times. This can be adjusted. We can say that every information piece has to be entered 10 times or 8 times or 5 times, that we experimented with it. And now we ended up with that everything has to be entered twice. It's usually sufficient to achieve very good data quality. If citizen scientists disagree on a certain piece of information, they usually try to resolve this themselves in a forum. If they still can't agree, then our herbarium staff members give support and try to help them. Then there's a certain gamification factor implemented in the system. First of all, you can reach levels during your work. You start with very easy tasks, and the more you work, the more experience you get, and the higher the level is you can reach. And the second thing which is implemented are so-called badges you can earn. And that's all in German, sorry, but I can translate a little bit. Sherlock, for example, you get if you derive new information from existing information. For example, you have a historic locality name and derive the country from today or the coordinates or things like that. Vollender is finisher, somebody who finishes things, gets things finished. Nacht is about it's night. It's people working at night, and so on. The forum is extremely important for the system. So users are very actively discussing their all specific things about old locality names, specific handwritings of collectors from the 19th century and so forth. So they are very actively discussing things in the forum. Also, they try, as I said before, resolve difficult things where they disagree. They give assistance to new users. So that's very for us, it's very efficient that they do it usually themselves. If somebody new comes in, he or she gets help from the old users, so to speak. And the whole thing is moderated by a student assistant at Berlin Botanic Garden. So that's very important to give them the feeling that somebody's there and answers their questions and so forth. And there is a new, let's say, side product of the whole system, which is called Herbonauten Wiki. That's extremely valuable. It has grown over the years tremendously and provides comprehensive information on herbarium collections in general, but also about specific things around transcription, standards for capturing elements, interpretation of handwritings, historical locality names, workflows for georeferencing, and so forth. It's really it's a very rich information resource, presently available in German only, but we are planning an English translation for that. Beyond label transcription, we would like to experiment a little bit with new tasks for the Herbonauts. One of the things we did was to ask our citizen scientists to capture morphological data from specimens, such as number of plant parts, flowering states, hairs, predation, clonality, and so forth. And we found out that they are very interested to help us with these more complicated tasks, but it creates an increased effort on our side, because describing this in a way that they understand it correctly, or let's say not consistently, so to speak, is a major task, and we really have to learn how to do this in a good way. But it's actually the whole approach is very promising, I would say. So what's next? We would like to further experiment with applications which are not label transcriptions, like I said before. Apart from the capturing of descriptive information, we could think about printed lists of observations, for example, or historic species inventories and things like this, which could be captured. We would like to achieve a better integration between different citizen science platforms, for example, between Tdwg and the Herbonauten, but also creating pipelines to large infrastructures such as Disco. We have a little project starting in the context of the EU project Tdwg, which deals with exchanging missions, and that's a project between presently between Paris and Berlin, where we are identifying French specimens in our collection, which then are worked on by the French citizen scientists and vice versa. The main purpose for this is to widening the community and to create some kind of transnational collaboration, which I think is very nice. And finally, we started to work in the context of a master thesis by Markus Ernst to develop AI methods to classify herbarium sheets as to whether they should be preferably tackled by citizen science pipelines or by AI pipelines. So the AI looks at the specimen and says, this can't be handled by another AI, it should go into the citizen science pipelines and vice versa. And we are very much looking forward to the results. And that's what I have for today. Thank you.
Thanks, Anton. Very interesting presentation. Are there some questions online? I don't think so. I didn't see them. So let's go to the audience.
Hi, Siobhan. I started out being a transcriber at the Smithsonian Transcription. That's where I entered this community. So I'm curious to know, other than the training you provide them when they first hit your website, do you offer any more development for the citizen scientists? Like, do you offer for them to come in and talk to your scientists back of house doors, or that sort of suite of offers?
Of course we do. No, we organize several workshops on specific topics where people could come to the garden, talk to us, talk among themselves, see the faces for the first time. And it was also for us, it was a great occasion to learn how they are, because they are, I mean, largely anonymous for us. And it was very interesting to see the background. They all, most of them, the most prolific citizen scientists have some kind of academic background, but not in botany. They could be, I don't know, medical doctors, mathematicians who just have a lot of time after retirement and became interested in this kind of work. It was very interesting. Then during Corona, we switched a little bit to video conferences, then more specifically on topics around, for example, georeferencing and things. And we are now planning to organize workshops again. Question is how this scales up. I mean, we have now 600 Herbonauts. If 10% come to a workshop, this can be handled. If you would have 6,000, I don't know. Let's see.
Yeah. Thank you.
Yeah.
I do have a question.
Oh, yeah.
Just when they take the training, do they get a login? I'm just asking, is there a check, right? So they take the training course, and then does someone give them an okay and allow them to proceed, or they can just sort of dive in and get going?
No, the training course ends with a little quiz, multiple choice, and if you successfully run through it, you are ready to go.
Okay, so
there's no human interaction.
Oh, okay.
No.
Yeah.
Okay, there's a comment in the chat from Alan Stenhouse. He says AI models can help with many of these aspects. As we have seen during the conference for transcription, integrating this with citizen science for verification could be useful. Trait extraction, etc. might also be assisted by AI models, such as segment anything.
So it's not a question, but I will answer anyway. That's exactly the idea of this master thesis I spoke about, to automatically identify whether something should be done manually or rather would qualify for a more automated AI-based pipeline.
Okay, we have 15 more minutes for questions to all the presenters. I will start myself because I have a question or two for Anton. The work that you are doing for assessing the quality of the digitization work, do you think that is something that could be automated and could be integrated with the digital specimen? So having an automated assessment of the quality of the information.
So what we are doing to assess the quality is actually we are taking specimens for which we have high quality metadata already. The data are re-entered by citizen scientists and then we compare. So I guess the answer to your question is then no, because you couldn't make this comparison between existing data and new data, so to speak. I'm not sure, but I think, yeah, no.
Another question, Anton? Sorry. The training that you offer for people before they test the digitization, do you think it's something that could be adjusted also for the annotations in other systems, like the annotations in the digital specimen?
Yes, I think there's nothing against it. It's just a list of questions, actually, and then first a little explanation on, for example, where you find a collector number on a herbarium sheet, and then you get a list of example specimens where you have to find it and enter the information. And you could, in a similar way, you could actually create a training on every user interface or system, I would say. So yes. Mm-hmm.
Good. At least one, yes. Any further questions from the audience or comments?
So I have one more question for you. One of the things I do when I do transcribe labels during We Dig Bio, which is a worldwide campaign twice a year, it's when I devote myself to this, my workflow is to go through, transcribe a specimen, find the collector name, and then I actually extend my workflow and go research the collector, double check that they're in Wikidata. If they're not, add them in Wikidata, then go to Binomia, attribute all their specimens to them in Binomia, and then add the Binomia ID back into Wikidata, and then go and transcribe the next label. Have you thought, would you consider teaching them that?
Yes, we considered this, actually.
I've got how-tos on all of those so if you want it, I can provide you with documentation as to how to go about doing that.
Would be very nice. It's
okay.
The only thing is that, I mean, you are a very experienced citizen scientist, so you're used to orchestrate several systems in parallel. And
I know.
That's a little bit tricky. You really have to be advanced to do this. But
you've just told me that the people who are doing this work are ex-physicians, highly educated people. It's not that hard.
No. I'm sure they can do it.
Yes.
Yes, please send me the information.
I will do.
And,
I will do.
It's interesting.
Yeah. Okay.
Thank you.
Yes.
There were other speakers as well.
Yes, there are other speakers. Any more questions? No more questions for all the speakers. We still have some time. Oh, okay. Okay. So if there are no other questions for other presenters, let's go back to Anton.
It's a very short one. What happens if they fail the quiz?
They can't log in and go further. As simple as that. I mean, the quiz is really not rocket science. If you fail this one, I'm not sure.
No, but I was mostly thinking from the perspective of bots trying to get to login, and the quiz would be a blocker, but if they could keep redoing it, it wouldn't be. So,
yeah.
I'm looking if there are more questions. Any further comments, maybe? Everybody wants to go to the party, yeah? Okay, I think then it's time to end the session and give you a few minutes back. But before we do that, I would like to thank a few people. First of all, I would like to thank Anton for co-organizing this session. I would like to thank, of course, all the speakers in the session. But I would also like to thank our technical staff, technical team, for running this session so flawless, as all the other sessions in the meeting. I think it was very good. So maybe a little applause. Okay, and then finally, I would like to remind you that the session will be made available soon as a recording, so you can watch it again if you want. Thank you for participating, everybody. Thank you.